Okay, here is an answer key for the review for similarity unit. Okay, so start off, you got to know for problem number 1, which way is this thing going? Is it is the pink shape my beginning shape and enlarging to the black, or vice versa? And if I read the instruction, says the pink figure is the dilation of the black, which means I am shrinking. So this is my initial, and I'm shrinking down to the small one. Now, it already says they're going to be similar. I already know it's a dilation. I just need to know the scale factor. So I can pick any specific side. Maybe I will take a look at, I'll keep it simple. How about the tops here? So I'll take the top here, and I'll compare it to the top here. And if I were to slap some numbers up here, well, I know this is 4 units, or 4 boxes, and this is 1. Now, what type of fraction or ratio or scale factor I'm going to make? Now, since it's shrinking, I'm going to make a fraction that's small over big. Okay, anytime I want a reduction or a shrink, I have to have the scale factor small over big. If I want something to expand or get bigger, I would flip-flop those. So all I'm going to do is plop these numbers into the fraction, and I get 1/4 as my scale factor. So this is a reduction, and my scale factor here is 1/4. Okay, down to question 2. Now again, it already tells me they're similar figures, so I know this just looks like a plain old standard quadrilateral. Okay, same over here. I know that one is a smaller or larger version than the other. Okay, it tells me the figures are similar. Now I'm going to try to compare some sides. So here are 2 what we call corresponding sides. It would be really nice if it was a really easy scale factor. Like if I just, for example, if I said this was 12, it's simple, twice as big. And that means, or half as big, depending on which way you look. So if I wanted to match this, well, I know it'd have to be half of 48, half of 40, half of 40, all the way down, okay? But unfortunately, it's not as easy as a scale factor. Let me turn that back into 18. So again, is our shape getting bigger or smaller? Well, I'm looking for the numbers for all the small sides, okay? And if I were to compare those to what we call corresponding sides, I'm going to make a fraction that's small over big, because the lengths I'm looking for are shrinking. And I'm going to make a ratio out of this. And there's 2 ways to do it. So I could do 18 over 24 equals. Okay, so ratio, fancy word for fraction. This is the orange sides. Okay, I can always set up a proportion. Okay, and again, since I chose small over big, I've got to stick with it. If I'm going to do the yellow sides, the sides that match up, I would do small over big. Now, the way we solve proportions is we cross multiply. This times this equals that times that. So I get 24y equals 18 times 48. That's kind of a big number, so let me use my calculator. 18 times 48 is 864. Let's change the colors here. 864. Now, this is a one-step algebra equation, and the one step is dividing by 24. And this goes away. So 864 divided by 24. Enter. 36. So y equals 36. Make sure you put the right answer in the right spot. Okay, I would do the same thing to find x and z. Notice they're both 40. So once I do one, I don't have to do the other one. So now I would compare these. And again, I could do the same thing. So 18 over 24 equals, remember, small over big. So these are the blue ones, and these are the orange ones again. And I cross multiply. 24x equals 18 times 40. It's 720. And I can also do one-step algebra here, divide by 24. This goes away, divide by 24, and we get 30. Okay, now there is another way I could have done this. 30 and 30. I could have also figured out what the scale factor, like what is 18 divided by 24 as a decimal. And you might like this better, so I have to use a calculator for this. So 18 divided by 24 is my scale factor, 0.75. And I could literally just multiply. What's 48 times 0.75? 36. What's 40 times 0.75? And that is even easier math. So whichever method you choose, it's up to you. I'll pull it off. I'll save it up here for my notes. And I'll put it over here. Maybe I'll get rid of this and pull it down so I can use it in the future. Okay, let's go down to this one. Are the triangles similar? There are three methods for similarity: angle, angle, side, side, side similarity, and side, angle, side similarity. Now we put these little tildes here at the end, so they're not to be confused with congruency. Okay? Okay, looking at this one. I notice one angle, one angle. And if you look at the ends of these options, it's definitely not angle, angle. I only know one angle, so that's no good. For example, I have no idea if those angles are the same. And it doesn't help me to only know one. Now, obviously, also side, side, side. This isn't a right triangle, so I can't use the Pythagorean theorem. And I have no idea what that length is, so I can't check ratios. So right here, I wouldn't be able to actually plug in numbers for this one. So this is out, okay? So my answers are it's either side, angle, side, or they're not similar. Well, how do we know? Let's match up some corresponding sides and see if they are what we call proportional. I notice 15 is the smallest number in the small triangle, which means it has to correspond with 18. 20 is the largest number, has to correspond with 24. I don't care which way you do it, small over big, big over small. But once you do it, you have to be consistent. So let's say maybe I choose small over big. And I'm going to use this to make a couple ratios. So I'll do the blue ones here, small over big, and I'll do the purple ones here. And I'll see if they equal each other. So the small is 15 and 18. And you notice I did the small, from the small triangle to the big triangle. 20 over 24. Okay, I'm going to use a calculator, and I'll just see what those ratios turn out to be. 15 divided by 18 is 0.83 repeating. 20 divided by 24 is also 0.83 repeating. So I can check with a calculator. Or I could have also reduced these. Okay. I know they're equal because the one on the left, 3 goes into both of those numbers, so this reduces to 5, 6. And the one on the right, this also reduces to 5, 6. So they do equal each other. So if those numbers did not equal each other, then my answer would have been D. So the correct answer is C here. Okay, next page. Again, what are my options? It's either angle, angle, side, side, side similarity, or side, angle, side similarity. Now you'll notice I don't know any sides on this, so it's probably not the bottom two, but I can do this, vertical angles. I can also do this. If these lines are parallel, then these would be alternate interior angles. And so the correct answer on this one, and again, if I'm looking at all the ends of these, is it side, side, side? Is it angle, angle? Is it side, angle, side? Or does it not work? And the correct answer is angle, angle. Okay, this one. Again, is it angle, angle? Is it side, side, side? Or is it side, angle, side? Now, this looks a little bit weird, but if I were to unstack these, okay? So let me unstack these two pictures. So I'm just going to trace them. So here's my small triangle. Looks like that. And let me do a better job of tracing it. Let's try that again. Okay, boom, here's the small one. That looks better. And I pull it off. And I know that this side is 22. And this side down here is 14. And now I'm going to look at the big triangle. And that's this one right here. And you'll notice when I pull this one off, do you recognize that they have the same angle S? Okay, that's called reflexive. Okay, so if they both have the same angle, let me move this stuff over. And I'll move this over and get it a little bit out of my way. So angle S has to be the same as angle S. And then the top length is going to be the whole thing here. So this is 33 from there to there. And this is 21 from there to there. And I get 33 here, and I get 21 here. And let's make fractions out of these. Okay, match corresponding sides here. Okay, you'll notice, maybe I'll do big over small this time. Big over small. Big over small. I look over here. 33 over 22. And 21 over 14. Okay, do these equal each other? Well, 11 goes in the first one, so this would turn into 3/2 fraction, the top and bottom. And 7 goes into the other one. 3/2. You could also type these in a calculator and you know, yes, they are, the ratios of the sides are what we call proportional. So again, looking at my options, at the end, well, it's not side, side, side. Looks like it's side, angle, side. It's not angle, angle. And here's my correct answer, B. Next slide. Okay, I notice these have one matching angle. So obviously it's either angle, angle. I don't know anything about the side, so it's not going to be this. It's probably not going to be this. I don't know any side length, so it's either A or D. 31. Now, first glance, you'll notice, well, this is 30, but is that 30? And this is 15, and is that 15? So I'll use a calculator here. You do have to know that all triangles add up to 180. So maybe I'll focus on the little triangle here. Simple subtraction, 180 minus 30 minus 31 means that big angle is 119. And so this is 119. And obviously the other one's not going to work either. 180 minus 115 minus 31 is 34. 34 degrees. Okay, so these triangles are not similar because they have to have at least two matching angles. All right, question number 7. Now, this does not deal with similar triangles, but it does have the properties of proportionality. Now, there's two ways to do this, okay? And this only holds true if you have an angle bisector. You can make this into a fraction and make these into a fraction. That's one way to do it. Okay? Or you could make like the bottom half that's bisected into a fraction and the top half that's bisected into a fraction. Either way works. I don't care how you do it. I'll probably do it this way and say, okay, 12 over x. You'll notice I chose the side that was split up by the angle bisector to be on the top. Well, I have to do the same thing over here, equals the side that was split up by the angle bisector has to be on top. And I get 10 over 15. Okay, unlike the last ones where I was just checking to see if they're equal, this one I actually want to solve for x. So I am going to do some cross multiplication here. This times this equals that times that. Let me move some of this stuff over real fast. I get 10x, get rid of that, equals, let's use the calculator, 12 times 15 on, is 180. And now it's a simple one-step algebra problem. Opposite of multiplying by 10 is division, and x equals 18. Okay, question 8, same concept. If these lines are parallel, okay, I know the triangles have to be similar. So we got little baby triangle here. We have papa triangle. And I can also break up the parts of the big triangle. So for example, I can make these highlighted in orange and yellow into a fraction. X over x minus 3. And I can make this part here on the bottom segment into a fraction, 2 over 3. Now, before you start cross multiplying, I notice this denominator has a couple what we call terms, or a couple items. Group them. Okay, now cross multiply. This times this equals that times that. I don't care which one you do first. I'm going to do the blue stuff first. And here's where the parentheses come into play. You have to have those parentheses, so you distribute. I get 3x equals 2x minus 6. Okay, and now I'm going to go ahead and plug in my answer here. I'm going to go ahead and get x to one side. Oops, hold on one sec. Okay, I had to pause for a minute because I was like, something doesn't look right. Like, why would I have a negative number here? But when I look at my actual problem here, I guess it didn't copy over correctly. Hopefully you notice it's x plus 3. So let me fix that. So this should actually be a plus 3. For some reason, it didn't carry over when I transfer that. All right, that looks better. Okay, so now I'm going to subtract 2x from both sides. And conveniently, hopefully you notice x equals positive 6. Now, I can check it and make sure. Let's see what happens. If I put a 6 here, that looks good. And if I did 3 more, this would be 9. And 6 over 9 does reduce to 2/3. Perfect. Okay, so it works. Okay, this is the same concept. I'm going to break it into parts. Now, this doesn't deal with triangles, but I can make this into a triangle if I extended those lines. So here are my parts. I'm going to break these into a fraction. I'm going to break these into a fraction. I'll do the math over here. So 2 over 5 and 9 over x. I just put the 2 over 5 because that's how it looks in my diagram. I'm going to go ahead and cross multiply. I get 2x equals 45. And this is a one-step algebra problem. divided by 2. Now, I don't really like that this says type your answer as a simplified fraction, so be careful here. That's my simplified fraction. 45 divided by 2. If they ask for a decimal, okay, then obviously I would type into a calculator and I would get 45 divided by 2. It makes a nice clean decimal, 22.5. Okay, let's move on. Okay, and notice these are split in half. These are split in half, which means this is half of that. Okay, a common mistake is people just think that they have to do division, 96 divided by 8, and they get this. No, that is not. That would be the case if, excuse me, this were 96, but it's not 96. It's half of that. Okay, and what is half of 96? It is 48. Okay, so that means from here to here, this distance from here to here is 48, which means x has to equal 6. Because when does x, or 8x, equal 48? Okay, next problem. These are similar right triangles. Okay, what I recommend doing on these is taking all of these triangles off and orienting them the same way. So I'm going to go ahead and I'm going to flip this thing, flip, and I'm going to rotate, and I'm going to make it so the 90-degree angle is down here in the lower left-hand corner. Okay, which means the 90-degree angle here I would call G. And I'm going to talk a lot about short side, long side, and hypotenuse. I notice this goes up to F, because this is my short side, which would match up with my short side. And down the long side here goes down to E, which matches up with this, E. So orient them so they're all in the same direction. All right, now let's do the medium triangle, right? Sure. So I'll do this one in orange. Let's try again. Boom. And I'm going to go ahead and pull it off. I'm going to go ahead and rotate it. I'm going to get the 90-degree angle down in the lower left-hand corner. And I notice this is at H. And if I went up the short side here, I would be to G, which is up here. And down the long side, down here to E. Okay, last but not least, the small triangle. This one's probably the easiest, but just a slight rotation. And H is the 90-degree angle, F is up the short leg, G is down the long leg. Okay, now it's a lot easier to look at these. So I'm going to go ahead and highlight in blue here since I haven't used it yet. The first one, E, F, G. E to F to G, okay? Does it match up with E, G, H? E to G to H. Ooh, it's looking good so far. And G, F, H. Oh man, we got it on the first try. So the correct answer is going to be A in this scenario. Okay, I'll just do another one so you can kind of see like an incorrect one, what it would look like. Like if I did the other one, I'm going to go and trace this triangle the incorrect way. So they say E, G, F. E to G to F would be this one. And then I can write, the next one says E, G, H. They're not tracing the triangle the same pattern. Okay, on to the next problem. Question number 12. Get close to the end. Okay, so we're looking for the distance D here. And if it helps, if you need to orient the triangles so they look the same, for example, go ahead and do that. When I make my proportions, I like to line things up. So if I flipped it around, so they both have this 90-degree angle in the lower left-hand corner. Okay, then this would be 150, and obviously this is not drawn to scale, and this would be 30 right here. Get rid of that. So if that helps, go ahead and do that. Or some people can just line it up and look and see what parts match up. Okay. I do know that these angles have to be the same because they're vertical, and these are both 90, so they're similar by angle. Okay, so let's start making proportions. So I'll start with the vertical sides here. D here matches up with 150. I don't care if you do small or big over small. I'm probably going to do big over small for this one. Once I choose, I got to stick with it. So I'm going to go ahead and put D, which is the vertical side, which is on the big one, over 150, which is vertical on the small. If you prefer to just look at it here and match them up, that works as well. Okay, then I will look at the horizontal, which matches up here. Equals 75 is big, 30 is small. Again, if it helps to look there, your choice. Now we have a proportion. Cross multiply. We get 30D equals, use my calculator. Put it over here on clear. 150 times 75. Big number, don't panic. And the final step would be division. Divide both sides by 30. Boom. And I'll divide that by 30. And we get 375. Okay, let's move on to the next one. Question 13. Okay, on question 13, I do have to be a little bit careful, because in the past we have broken up triangles into parts, like, oh, I'm going to make that into a fraction. Okay, it will not work if you try to do this and make that into a fraction. If I was looking for these up here, yes, absolutely. If these lines were parallel, I can break the parts that are getting broken up into fractions. But I can't do that when I'm talking about the parallel lines here, okay? Now, it does tell me, there's a little hint here, that the corresponding side of the long triangle is 148. That's this whole thing, okay? So again, if I were to pull them off and do quick little sketches, so this is my small triangle, and I pull that over here, and I get 41 for my vertical side, 82 for my horizontal side. Maybe I'll pull it off even more. And then I'll do the same with this big triangle. I'll highlight this one in blue. Big triangle. And I pull it off. And I get 184 for my horizontal side. And I get N here for my vertical side. Okay, now I can set up a proportion. Okay, I don't care how you do it, big over small, small over big. Maybe this time I'll choose small over big, as long as I'm consistent. So maybe I'll look at the horizontal sides first. So small over big would give me 82 over 184 equals. Now I'm going to look at my vertical sides. Again, since I chose small over big, small goes with 41, big goes with N. Cross multiply. Boom. Boom. I get 184 N equals, oops, did it wrong, excuse me, 82N equals, and I'll use my calculator here, 184 times 41 gives me this, 7554. goes here. 7544, excuse me, let me say it right. Now it's a one-step algebra problem. Divide by 82. And I'll divide that number by 82, and I get 92. And equals 92. Okay, very similar problem here. I'm going to make sure this actually says 11. It looks like 11 to me, but I'm going to double check. So let me get my thing out here. And yep, 99 and 11. Okay, maybe this time I'll just make quick sketches. So if I were to pull these off, I don't have a ton of room here. So I've got a big triangle and a little triangle. Oh. So here's my big triangle, okay? And I am looking for the height of this tree from here to here. And then I'll sketch another one just like it that's similar. So this is the big triangle. And obviously not to scale. Here's my little triangle. I know they're similar. I'm just trying to match up corresponding sides. So this is 6. This is h. I can make that into a fraction. This is 11. And the whole distance from here to here is 110. Okay. Now, let's go ahead and set up our proportions. Let me put in the 110 here. Okay, again, I don't care if you choose small over big, big over small. Maybe this time I'll do big over small. I'm going to do big over small, and I'll do my math up here. H over 6 equals big over small. 110 over 11. Cross multiply. Boom. Boom. I get 11h equals 660. One-step algebra problem. And I get h equals 60. Okay, last but not least, midpoint. Here's the formula for midpoint. X plus x divided by 2. Y plus y divided by 2. You'll notice I didn't put y1, y2 because I don't care. When I use addition, it doesn't matter what order. X and x. Y and y. So I'm going to put the x's in the x spots. I'm going to put the y's in the y spots. All right. Let me scroll down a little bit. So I would get 6. Now when I add a negative like this, it really turns to subtraction. And -5 plus 10. Now sometimes you'll get whole numbers here. Sometimes you won't. This is -1/2. And this is -5 halves. Now, it's nice when these are whole numbers, but if they're not, you can type them in as a decimal, and I believe this one wants a decimal answer. You do have to be very careful. It says type an ordered pair. So number one, if you were going to type this in on the computer, you would have to have a set of parentheses. And I'm going to say -0.5, and I have to have a comma, and -2.5, and I have to close my parentheses. With no extra spaces, hit enter, you'll get the answer correct. Hopefully that helped. Now you're ready for the similarity test. Good luck.